So, in the last lecture we discussed about the stochastic process introduction. We said that the basic difference between stochastic and random is that more or less they are same, except that stochastic process gives you a realization of the signal or the input or the data which can be trusted. Why I am using the word trusted? Because the ensemble average of the sample of a single signal is as same as that of the time average. So, one can define this by two ways. One, make it mean ergodic, make it autocovariance ergodic. A classical example of the system, which is a stochastic process, can be the wave amplitude. Now, one can really understand a very interesting physical meaning of considering the process to be ergodic for the stochastic process is, let us take this specific signal. Let us have a signal like this, which is along the time scale. Maybe the signal is maybe after specific window, let us say the signal continues. Now, I have a mean value or any specific value of exceedance. Let that value be drawn here. Let us call this value as some x. So, what I am interested is to know what is that sample which is less than or equal to x over a time, and then average it for the record of t, where t is actually the record length. Let us say I start my record from this point to, let us say, this point. So, this becomes my t, what we call as record length. Now, I am looking for the time at which the sample data is lower or equal to some specific threshold data or some control value or some representative value within the signal. So, if I read the signal, then I can easily point out these are the values which are lower than the x. So, I can call, for example, this as delta T1. Similarly, I can call this value as delta T2, similarly delta T3. Delta T3 are nothing but the time values. So, as I proceed, I can call this value as delta Tn, where there is my n value. So, explicitly this can be written mathematically like this, which we call cumulative distribution function, which is CDF expressed as capital F x of t of f, which is now going to be mathematically the limit t tends to infinity t of x of t less than x of t. So, the explanation of what we are given here is mathematically nothing but the cumulative distribution function. Why cumulative? Because I am looking at the record from 0 to t. So, it is cumulative. Why is distribution? Because I am looking at the distribution of the entire signal for the whole record length capital T. Now, you can interestingly see this is going to be actually time average. Okay. This validity is applicable only when the process remains stochastic, which is now mean ergodic as well as autocovariance ergodic. So, therefore, to make or to apply a stochastic process or a stochastic dynamics in a given process, the process should qualify to remain as ergodic, otherwise you cannot do this. Okay. So, let us quickly see some of the classical, let us say, parameters which are required in stochastic analysis. One was what we call the cumulative distribution function, which we already said there, but let us formally write it out for any random variable. Let us say the cumulative distribution function f of x of a random variable capital X. Suppose I wanted to find out the cumulative distribution function of a specific value of x t1 of x for over a record length limit n tends to infinity. So, average of n of x t1 less than x. So, in this case I am using capital X because is my variable. Then the next important parameter which people look at is which is indicated as small f of capital X of x, where x the random variable which is the differential of the CDF. So, I will call equation number 1, equation number 2. So, by this definition, hence the cumulative distribution function which is f of x can be an integral of the probability density function which is f of x s ds, whereas the integration is only from minus infinity till x. The reason being the cumulative distribution function is checking the periodicity or the validity only with respect to x, that is the reason. Because here this is nothing but expanded as any variable or any variable less than or equal to a control value. Okay. Therefore, the integration of the function only will be from the negative value of infinity to that of the positive value alone. Okay. That is the reason why we are saying this way. So, this can be a reverse function like this, is integration of the PDF which can be obtained. Once we know these two, one can find the mean value. Mean is otherwise called as expected value of the variable x is given by, is denoted as small m of capital X, because x is the variable. I am deliberately using capital X here, taking x as the variable just to make it clear that where we are substituting capital X. Okay. So, m of x. Mx can be given by a simple expression which is expected value of the variable this is equation 5. Now, remember interestingly the mean actually considers of the variable considers the value from all the bounds. Okay, that is represented actually here, whereas the PDF is only considering the bound from the value of infinity to x, because x actually threshold value for fatigue CDF. Okay. So, mx can be given by this. Let us retain this equation, because I need this equation later for comparing for another case. So, we will have this equation ready with us. Now, let us take another parallel example and derive mx in a different understanding. Let us say, for example, I am looking for length of the table. Let us take length of the table is a variable. Why it is a variable? Because it is a random variable. I already said yesterday, random variable is that number or the term random is the variable can take any value in a given set, but the variable already has a fixed assigned number. We do not know that value, therefore, we are selecting it randomly. Why randomly? A person will say the length of the table is 5 meters, other person will say the length of the table is 5.1 meter, it say 2.2 meter. All these are random numbers, but the length of the table is neither of them or all of them, but however, the length of the table L is a fixed value, okay. So, it does not change. Though the meaning is a variable, the variability comes only on choice, but the value is fixed actually, okay. So, let us say I want to check the length of the table, which is a variable S, x, which is a random variable, and obviously length of the table will be normally in a whole number, okay. We do not have length of the table as 5.15 unless otherwise you are converting feet into a meter or vice versa, generally it is a whole number, okay. So, we do not want any fractional numbers in this. On the other hand, x can take a specific value, let x can take only specific values. For example, you may say how specific value? Length of the table cannot be 1 millimeter, I mean. So, it cannot take a random value of highly random in nature, okay. So, it has got a specific value only, some decent assumption, okay. So, it has got a specific value, let that specific value be x of k for k equals 1 to up to n. If one is interested to know the mean of this value, okay, if one is interested to know the mean of this, because it is now taking the random variables, I want to know the mean of this, okay, because I am talking about the variable as capital X, say mx here, which can be simply sum of all possible values varying from k equals 1 to n, that is the variable here, of that of x of k, that is the value what it can take, multiplied by some p of k. So, what is p of k? Where I call this equation as equation 6, where p of k is the probability x will be exactly equal to x of t, okay. Yes, x of t is a whole number, k is the count, k is the count, okay. This is k actually, I do not know whether you are able to see it, this is k, k is the count, there is no t here. Let us say equation 7. Alternatively, mean can be also expressed as, I can also express mean the other way, the average of all the values assumed by k. So, mx can be also limit n tends to infinity 1 by m of 1 to n x of g, equation 8. Now, interestingly, if you look at equation 6 and 8 or equation 6 and 8, 6 and 8, both are of a different form actually, because in 6 we do not have an average over the sample data, and we have a probability of the chosen value of x associated with a whole number what it can assume, whereas in 8 we do not have that condition. It is a simple average, okay, but both are giving mean. So, I must be able to connect them statistically. Both are actually mean. This is also a mean equation for finding out the mean of the variable. This is also, okay. So, I have to connect these two statistically. Let us see how to bridge this. I will retain this equation as it is. So, now I have two equations. One is mx is summation of k equals 1 to n xk of pk. The other is mx equal to limit n tends to infinity 1 by n of sum of j equals 1 to n x of j. So, I ought to bridge this, okay. They are both are mean. Now, to bridge this, let us discuss one more example. Now, the aim is to connect equation 6 and 8. Why? Both are actually m of x. I want to connect this. Now, let us take an example. The example is we are conducting some experiments. Some experiments are carried out. Let us say n set of values. You got some n set of values. The outcomes of the experiment are x1, x2, xn, where n is sufficiently larger than n, okay, sufficiently larger than n. N is sufficiently larger than n. Now, it means that x can assume any value between either n or n, because both are mean, okay. That is, it can take x1, x2, x3 up to xn, but amongst these values of what x is assuming, all values are not relevant. Why? Because we already said x cannot take certain values beyond the bound of this. For example, length of the table cannot be 1 millimeter, though 1 millimeter or 1 is also a random number, but it cannot take. It means it is not that bound of n it can take, though n can be very higher than n, but my mean should be bounded only on certain chosen values which are relevant to the data. This is called physical realization in stochastic process. This is where we are different from random process, okay. We have to physically realize this value to that of the example or the problem. So, it means the x can take any value because both are giving me the mean, but there are amongst any value there are only relevant values of x1, x2, x3 till x small n, okay. Now, x is assuming any value, but only these are relevant. It means there are groups, okay. Let nk be a group where x has assumed the possible realized values. Why nk? Because k is the count for n. K is the count for n. So, what I am doing is amongst the value what capital X can take, I am grouping them in such a manner that some are relevant values, some are irrelevant values, some are imaginary. I am forming groups. Let one group of nk represent those k values based on which the mean was calculated, okay. 1 by n of summation of j equals 1 to capital N of xj should be made equal to summation of k of 1 to small n x of k is the pk we said is nk by n, where why or because the probability of k which is suiting the value. What is the probability? You understand this. For example, in a classroom one person says the value or the length of the table is 1 millimeter, okay, 1 meter. I associate a factor or a multiplier to that value, say that this is irrelevant, so the probability of accepting this value as my table length is maybe 0.001%. So it will automatically deplete the contribution of this number on the mean. Okay. So the pk is nothing but the probability value of the realization on the original sample. You understand? If the real table length is 3 meter, somebody says 3.1 meter, then the probability will be, say 95% or 90%. Okay, that multiplier will take care of the relevance or realization of this value in the original sample. Now this realization or the multiplier realization in terms of probability is now converted to this because pk is nothing but limit n tends to infinity nk by n. Is it okay? For example, you have only 6 numbers. So nk will be 6 and n is also 6. So all your values will have a probability of 100%. So the mean will be exactly equal to the average of those 6 values, which will be same as this. Okay. So if my pk is giving this validity, these two means will converge with the same value. Okay. One is for the random process, one is for the stochastic process. Okay. Having said this, then in general the expected value of any variable g of x is then given by, I want to generalize this, which is m, because initially when my random variable was x, I wrote this as mx. Now my random variable is g of x, so I should say this as mg of x. Okay. When my random variable was x, I wrote this as expected value of x. Now I should say expected value of g of x. When my random variable was x, I should integrate this to from my PDF as a multiplier of x, PDF of x, in this case g of x, f of x dx, where this is equation number 9, where g of the function, maybe any function, gx, gy, etc., whose integration exists. Okay? That goes without saying, otherwise you cannot integrate this. Parallelly, then let us work out the variance. Variance x is given by, now one can people ask a question that what is the importance of variance? Let us say standard deviation, which is the square root of variance, is important because it is a measure of spread or variability of the data or, to be very specific, outcomes of the variable. It will tell you the spread of the outcome of the variable. Okay? So, it is very important. Therefore, one should know how to calculate the variance for the given variable x. So, variance of x is generally indicated, can be also called as sigma x square, because it is sigma x is the standard deviation which is square root of the variance, which is nothing but the expected value of the variable minus the mean. Square. Let us write it properly. This is square. The expected value of this function. Now, I want to substitute this back here, okay, because mean already we know is given by this function. Okay. So, therefore, sigma x square or variance can be given by an integral of minus infinity to plus infinity. G of x is x minus m of x, and integral of PDF of f of capital X small x dx. Equation number 10, 11. Having said this one is square, no? Square. So, one can expand this expected value of x minus mx square, which can be said as expanded value of x square minus 2 mxx plus mx square, which can be mathematically said as expected value of x square minus m square x. Equation number 12. Hence, sigma x square can be now written as limit n tends to infinity. This is 1. So, which is going to be 1 by n of summation of x j equals 1 to n of square, that is what it means. Okay, let me use a different bracket here, minus, I am now talking about this, which is 1 by n of summation of j equals 1 to n of x j the whole square. Equation number 13. Now, one can ask a question, what is the interest of finding out the mean and standard deviation, which are first order statistics of a given random variable? If you know both the mean and standard deviation, I can find out the coefficient of variance CV or Vx. Okay, let us, this is symbol is Vx. Vx is given by the ratio of sigma x by mx. Equation 14. Of course, for mean, not for non-zero mean process, for mx not equal 0, because there are some process which is zero mean process. Now, one can ask a physical question, what is the importance of finding out CV or Vx? Indication of Vx will qualify, or let us say quantify the fluctuations of the variable with respect to the mean. Let us physically see this question. I have a cube. Let us say the cube is designed to be M25. It means the characteristic compressive strength of this cube should be 25 Newton per millimeter square after I cure this cube for 28 days. So, how do I do it? I test it in a testing machine, fail the cube or crush the cube and find out the crushing strength of the cube. I have cast 100 samples, found out all the data. Okay. Now, one can easily find the mean and standard deviation of the given data from this equation. Mean is nothing but sum of all divided by n, and standard deviation is nothing but the equation what we already have we can find. If you know the value of Vx, you will exactly know amongst the 100 sample which has come from, let us say, 10 different sources. You can easily find out if the variance is very high, then it is away from the mean, then the sample is either too strong or too weak. So, it will give me the fluctuation, not give me good or bad, it gives me a fluctuation with respect to the mean of the given problem. Okay. So, it is a good index for people to know what is that sample which is either too bad or too good from the given lot of n, which is 100. So, this will help you to group the sample in terms of a category. You can say sample which is having closer to 98 to 100 can be group A. So, this will help you to do that. Okay. So, that is the requirement. Therefore, in a given stochastic process, easily if the variable is following an ergodic process which has got mean and autocovariance ergodicity defined in the given sample, single sample from the given ensemble is qualified to represent the whole ensemble as an input data, for example wave load. For that sample one can find the mean and standard deviation, and you can take it forward for finding out the defining the load in terms of statistical properties which will be used in dynamic analysis directly.